Hello everyone. Today let us discuss a very interesting problem. The probability that x by y is closest to an even integer and x and y are chosen from the interval 0 to 1. Okay. So we basically need to first understand what does it mean when someone says that a fraction is closer to an integer. So it's closest to an even integer, which means take any integer, okay, 2, 4, 6, whatever integer you can. Obviously, we will be talking about positive integers because the ratio is positive. But what does it mean that this is closest? Now, a ratio, so for example, the ratio in question, say x by y, this is said to be close. So is said to be to closest to n, where n is an integer. I'm not talking about even integers for now. So it is said only and only when n minus half is less than x by y is less than n plus half. So do you understand that n minus 1 or n plus 1 cannot be nearer to x by y than n, because x by y is situated at a point which is greater than n minus half. So you have already examined the avenue of that. So let me draw a picture which might depict it very beautifully. So let's say this is my n, okay? This is my n. So if this is my n and this is my n minus 1 and this is my n plus 1, these are the three consecutive integers that we have. Now, the difference between n and n minus 1. So what I'm going to do, since the gap is 1, the middle point is nothing but n minus half. Similarly, the middle point is nothing but n plus half. Okay. Now, the ratio basically can lie anywhere in this region. If it does, then its distance from n is always lesser than its distance from either n minus 1 or n plus 1. I hope my point was clear, how you can understand this from this simple diagram. Now, with that said, we can basically try and evaluate it mathematically for now. So if you multiply it by 2 and multiply by y, because those are positive ratios, positive numbers, you should simply get 2n minus 1 times y less than 2x and less than y times 2n plus 1, correct? Now this represents a set of two equations, two inequations I should say. So the first one should be something like this: y is less than 2 by 2n minus 1x, and the second one should be y is greater than 2 by 2n plus 1x. And you also know that 0 less than x less than 1 and 0 less than y less than 1. Ideally, what they are going to plot, if you plot them actually for some values of n, of course, and I'm going to show you this visually as well. So while I'm drawing, you can see the visual animation of what actually happens when you iterate through the values of n. So if I were to draw it here as well, it would simply be, this is the point 0 comma 0, correct? Now this is my unit square. So this is my 1, this is my 1, this is my unit square. Okay. Now the lines would be something like this. So this is 0 0, and this is always going to form a triangle. Okay, so obviously this is the bigger point, and this is going to be 1 comma 2 by 2n minus 1, and this point is going to be 1 comma 2 by 2n plus 1. These are the boundary points, or the 3 points which are going to form a triangle, and every number in between this for a particular n is going to be a valid ratio choice. So every point is basically an x by y value, a possible candidate for x by y, correct? So all of these choices are going to be valid for each particular n. And this is what we are actually going to find out. So this ratio strip down further and further, and they become a very steep line when we go down. Now, therefore, the area of this triangle, if I denote it as an, is nothing but 2 by 2n minus 1 minus 2 by 2n plus 1 into 1 by 2. And this should be 2n plus 1 minus of 2n minus 1. So I think 4n by the square 1. And that should give you 2 by 4n square minus 1. Now, obviously, a special ratio occurs when you are talking about the even integer 0. And in that case, the triangle would be at 0, 0, and then I think at 1 comma 0 and 1 comma half or something. 1 comma half, and the area of this triangle is basically a naught equals to 1 by 4. Therefore, my total probability is simply going to be sum of all the even numbers, so a0 plus a2 plus a4 and so on. So let's just keep a4, a0 here, and then we can simply write this as n equals to 2 to infinity, and we are only talking about even n, then we can sum an, right? Or in other words, you can simply write 1 by 4 plus summation n equals to 1 to infinity a 2n, I guess, right? Yeah. Now, 2 by 4 n square plus 1, let me put the value here. So it's basically summation n greater than equals to 1, 2 by 16, so it's 4n square, 16n square minus 1. So let us evaluate this value, 1 by 4 plus 2 times. So 1 by 16n square minus 1, it's basically 4n plus 1 whole into 4n minus 1. So if you were to do this, it would simply write like this, n greater than equals to 1, 1 by 4n plus 1 and 4n minus 1. Okay. Now the difference of this 2 is 2, so which we already have. So this becomes 1 by 4 plus summation n greater than equal to 1. And this simply gives you 4n plus 1 minus of 4n minus 1. So it's basically this minus the summation of this. So I don't need to write it separately. Actually, I cannot write it. So this is a mistake from my part because we do not know if the series is converges separately. That's a mistake. You should write one summation only. So I'll just remove this one. Okay, just consider this is a big minus. Now, 1 by 4 plus summation n greater than equal to 1. And this is basically 1 by 4n minus 1 minus 1 by 4n plus 1. Now, let us evaluate this. This simply gives you 1 by 4 plus, now just evaluate the series. It's 1 by 3 minus 1 by 5. What is the next term? When n becomes 2, it's 8 minus 1, 7. So 1 by 7 minus 1 by 9. And now you understand what's going on here. Okay. So this is basically the series. Now, how do we evaluate this? Well, remember that tan inverse x, the integration of this, the tan inverse x differentiation was basically 1 by 1 plus x square, right? Or you can say tan inverse x is nothing but 0 to x dx by 1 plus x square. Now, if x is between 0 to 1, 1 by 1 plus x square can be expanded as a series, a geometric series with first term 1 and common ratio minus x square, and this simply becomes 1 minus x square plus x to the power 4 minus x to the power 6, and so on. Okay, this is dx, and therefore this becomes x minus x cubed by 3 plus x to the power 5 by 5 minus x to the power 7 by 7, and so on. So basically all the odd terms in the denominator with alternating signs. Put x equals to 1 here. Tan inverse 1 is 5 by 4, right? And this becomes 1 minus 1 by 3 plus 1 by 5 minus 1 by 7, and so on. Now you understand the part from here is basically what you need. So if I write it in the other way around, it's 1 minus 5 by 4 is your basically the required part of the series that we want, right? This much is clear, and therefore the total probability is going to be 1 by 4 plus 1 minus 5 by 4, which is 5 by 4, and this becomes 5 minus 5 by 4. Okay. I explained this series because I found in a couple of answers in MSc and others where this problem was discussed. Of course, it was a Putnam problem. They did not really care to explain the mechanics of how to find the series beautifully. So I think that was necessary. And also, this kind of questions are very useful in generating just the, just generating your basic understanding of probability and how to deal with logic in this kind of questions. Anyway, so if you did like the problem and the solution and you learned something, do let me know in the comment section. Thank you for watching. If you're new here, do subscribe. We'll see you in the next video.